So, thank you. Hello, everyone. I am really happy to be with you today to share my feedback about testing process concerning our data warehouse. And we will talk about how we implement CI2, especially for Redshift. So to present myself a little bit, my name is Ismail Addou. I have 4 years experience in data engineering and cloud infrastructure, and I began to write some articles in my Medium account. And today I will be talking about my last article. I dropped a link here for more details for the ones who want to see. So I work in Doctolib. It's a French company based in Europe since 2013. And for those who don't know Doctolib, our product is mostly known as a booking app for healthcare services and also for teleconsultation services. But this is just the only visible part of the iceberg because we are developing many other tools that offers a new work experience for doctors or healthcare practitioners in general and enhance the medical journey of patients. So about our data team, we are almost 40 Doctolibers now, working on many projects on AWS, but today I will focus on our subject, which is the data warehouse, where many of us are very active because we push an average of 25 commits per day, and we try to keep the time to production less than 1 day. If you code it the morning, you will find it the evening in production. So also we have the objective to keep SLA under 8 a.m., and this is so challenging for us because a high coding velocity is also a high risk of pushing code errors. So we are using Redshift, as you know. It is a relational database and a strongly typed one. Then every structure change should be explicitly defined in a migration script in order to avoid a failure in production. And also in our data warehouse, we are using many data marts that are dependent on each other in the same database, which makes them all vulnerable to failure at any point during the workflow. So we are not safe from code mistakes, from data source unpredictable changes that could come from outside, and what I call database conflicts. For example, when we have two commits, one will rename a column and the other is still using the old name in a new SQL query. We are not aware of this conflict only on production if we don't do a system that will prevent from that. So if you have a pre-prod environment and an access to real data, this step will be easy to set up, and even it could be a must-have to test issues that are coming from data, especially. So we automatically deploy and test a release candidate to pre-production during the afternoon. Once the tests are green, we are able to push to production. As we are using real data here, we're able to detect problems related to the data, like structural changes in data sources, overflows, or maybe queries that is taking too long, for example, due to a bad join. But when it comes to code mistakes and database conflicts, it detects them, but it is far from being the perfect solution because when everything is okay, it's okay. But when we should repair the problems that are only coming from code base, and that's happened more frequently, tests in pre-production with real data are heavy. It takes 3 hours to complete. So we have to fix the pre-production locally, manually, and push a fixed version later to the prod in the same day because we want to push in the same day. And this requires a lot of manual work for the duty. So we are a big team, and this could happen frequently, and one bad commit is enough to ruin the pre-production. So to have a better testing for problems related to the code base, which are the most frequent problems, this slide won't surprise you. We will implement a CI pipeline to detect issues coming from the code base only. So like code mistakes and database conflicts. So we moved from a detection approach in the pre-production to a prevention approach. So before merging to the main branch, a CI process should test all the workflows to validate whether the PR should be merged or not. So the good news here is that we will do the same as pre-production, all the tests, but without a need of data. So we can save time to have quicker tests. Therefore, we'll be able to run multiple tests in the same time with short durations. So what we need to do is create isolated environment for both Airflow and Redshift. So let's begin with Redshift. So we dedicated a new cluster with the minimal configuration possible, as we don't need data, we don't need performance. So you can imagine that for each PR, a CI will be triggered and it will create a temporary database that is very similar to production, but without data. So the best way to do that is to use DDL queries in the link here. In our case, we cloned the entire database. I can say thousands of assets in only 15 seconds. So we have our database for our PR tests ready. And when we try to test with Airflow environment, it took us 1 hour to complete, and this is much longer than expected. So we noticed that we have more waiting time between tasks comparing to the execution duration in Redshift. And this is due to the slowness of the scheduler. So the scheduler system rely on the metadata database a lot to orchestrate the tasks, and this costs very much in terms of performances. So we don't really need all the features of a scheduler. We only need to orchestrate. So what we did is that we implemented a homemade orchestrator based on Airflow library to make it aware of task dependencies according to the DAGs, and also to execute the operators that are coded in Airflow inside the script. So we moved from 1 hour of execution to only 5 to 7 minutes to execute all the CI pipeline, including the database creation and destruction, and also the migration that we do before beginning the scripts. So to summarize, we had two types of problems, and those that are caused by the data coming from outside. It couldn't be avoided completely, actually, for the simple reason that it could happen during the night or during holidays. It's not really related to our coding. But all the problems that are related to the team internally, the CI pipeline do the job perfectly. So to finish my speech on this word, we still push to prod every day, but we still have green lights everywhere. Thank you for your attention.